Good evening, children. So welcome to today's class. So this is Srinivas, your maths faculty. Yeah, let us go to the today's class. Before that, what are the points we discussed in this chapter, number system? So you learn about the prime factors, prime numbers, composite numbers. Am I right? Good. So there are again two types of prime numbers are there. Yeah. First one, twin primes. Twin primes, and second one is co-primes. Twin primes and co-primes. The co-primes are also called as relatively primes. Co-primes are also called as relatively primes. Okay? Yeah. So what are twin primes? So you know prime number, it is having only two factors, one and itself. So in that prime numbers, the difference between prime numbers is 2. That type of prime numbers are called twin primes. Okay, children? The difference between two prime numbers is 2, called twin prime. So difference between two primes. Any two prime numbers if you take, the difference must be 2. Example. Okay? Like 5 and 7. 5 is a prime number because it is having only two factors, one and itself. Same way, 7 also a prime number having only two factors, one and itself. And the difference between these two, 7 minus 5. Difference is 2, then these two prime numbers are called twin primes. Okay? Let us check some more examples, children. Like 11, 13. This pair of primes are called twin primes because the difference is 2. Okay? Same way, 17, 19, 20, 17, 19 also. You find some more. Okay, na? 29, 31. These two are also prime numbers. What prime numbers? Twin primes. Because the difference between them is 2. Clear? What about co-primes? What about co-primes or relative primes? So co-primes means if you take any two numbers, the two numbers having only one is the common factor. In the two numbers having only one is the common factor, that type of numbers are co-primes. Here one condition is there, that means one statement I am going to tell you that here two numbers always need not be prime numbers. Always need not be primes. Okay, na? I am telling the co-primes definition. Common factor of any two numbers is only one. That type of numbers are called co-primes. Now, one important point is if you take any two consecutive numbers are co-primes. Any two consecutive numbers like 31, 32. Both are co-primes only, because 32 having multiple factors. 1 can come, 2 will be the factor, 16 will be the factor, 8, 4, 32 also the factor. But while you're writing the factors of between these two numbers, only 1 is the common factor. Okay, only 1 is the common factor. So this type of numbers are called co-primes or relatively prime numbers. Co-primes are relatively prime numbers. Okay, na? So co-primes completed, twin primes completed. Now, so we discussed about a square number, right? Discussed about a square number. Okay, if not, again I am telling you that. What is the square number? When you multiply any number with itself, gives a square number. Like 3 is multiplied with 3 only. What is the answer? 9. So 9 is the square of 3. Here 9 is square of 3. That means any number is multiplied by itself 2 times are called square numbers. Are called square numbers. Yeah, for square numbers, let us see some properties. Let us see some properties. Yeah, properties of square number. Properties of a square number. It's not a square, not geometrical shape, square number. Yeah, first property, take any square number, the square number is never ends with the digits 2, 3, 7, 8. Never ends with the digits 2, 3, 7, 8. Any square number never ends with the digits. Ends with the digits 2, 3, 7, 8. Very, very important. That means if any number is ends with these 4 digits, it definitely is not a square number. Okay, na? It is definitely not a square number. Let us see that. Like 1 to 10 square numbers we observe. 1 square value, 1 ones are 1. 2 square, 2 into 2, 4. 3 square, 9. 4 square, 16. Yeah, come on, tell me. 5 square, 25. 6 square, 36. 7 square, 49. 8 square, 64. 9 square, 81. 10 square. Check unit place digits of every number. 1, 4, 9, 6, 5, 6. There is no 2, 3, 7, 8. These 4 digits are not appearing in its units place digits. That's why I clearly given that any square number is never ends. Ends means what? Unit place digit we should check. Never ends with the digit 2, 3, 7, 8. There is no presence of 2. There is no presence of 3. There is no presence of 7 as well 8. Okay, na? That is the first important property. That means by seeing we can check whether the number becomes a square number or not. But we cannot decide whether it is a square or not exactly. Next one, any square number, that means square number always, not for every square number. If the square number is ended with the digit 0, it definitely should have even number of zeros. So let us write this. square number ends with even number of zeros. How many? Even number of zeros. Sir, what are even number of zeros, sir? Even number of zeros. What are the even numbers? 2, 4, 6, 8. Like that many zeros should have its end. Example, 100 is a square number. 400 is a square number. What about 200? 200 also ends with even number of zeros, right? But it is not a square number. Then how can you say this one, sir, property? I said that the numbers which can be ends with the zeros, it must have even number of zeros. But here you should understand that every number which is ends with even number of zeros or need not be squares always. Every square number with zeros or ends with even number of zeros. But every number ends with even number of zeros or need not be square. That is converse, both of them. That you should understand. It should be a square number. It definitely ends with even number of zeros. But every even number of zeros does not end with, that does not means a square number. That you should understand. Okay? Right. Okay, na? So these are main two important properties. First one, it does not end with, that is 2, 3, 7, 8, and a square number always ends with even number of zeros. Even number of zeros. What about 1000? 3 zeros are there now. No need to check here whether it is a square or not. It definitely should. It's not a square number. Now I am giving one question. Find the square number from the following. So your options are 1, 2, 5, 3, 1, 444, 1, 000. So go through the options like properties. The square number never ends with the digit 2, 3, 7, 8. 3, 8. So two options are eliminated. Still two options. Second property, it should not contain odd number of zeros. 1, 2, 3. Odd number of zeros. So this is also eliminated. What is the answer? Okay, na? Without checking or without finding the prime factors of every number, we use these rules. Okay, na? Yeah. If you want, write. Yeah. Next, composite numbers. So number having more than two factors are composite. And here you should understand that one is neither prime nor composite. One is neither prime nor composite. Prime numbers means exactly two factors. Composite numbers more than two factors. So one is less than two factors. So we are treating one as it is neither prime number nor composite number. Clear? Yeah. Next, let us see that perfect number. Perfect number. What is perfect number? If you take any number, finding its factors, and you know how to find the factors of that, right? Finding the factors, add all of the factors, the answer is double to the number. The answer is double to the number. So simply sum of divisors or sum of factors of a number is double to the number. That type of numbers are called perfect numbers. Okay, let us see 28. Find all the factors of 28. You learn already. One table. Yeah, how many times? 28 obviously. Two table, 28 will come. Yes, 14 times. Three table, 28 won't come. Okay, three table is not coming. Yeah, three table not coming. Four table, 4 sevens are 28. Five table won't come. Six table won't come. Seven fours. 4 sevens, 7 fours, both are same. It is repeating, so I am going to erase this. So the factors are 1, 2, 4, 7, 14, 28. Add all of them, children. 1 plus 2, 3. 3 plus 4, 7. 7 plus 7, 14. 14 plus 14, 28. 28 plus 28, the answer is 56. Exactly double to the number. Or else, if you remove itself means 28. 28 also one of the factor, no? If you remove 28, then sum of the remaining factors will be 28. Okay, like that also you can remember. Sum of factors double to the number, you can say like that. Sum of the factors except itself is itself. So 28 is a perfect number. 28 is a perfect number. Let us check for 6 also. Okay, na? So for factors of 6, one table, two table also will come. 2 3s are 3 table. Yeah, 3 2s are also 6. But 2 3s are 3 2s are same. So here we are realizing this. So what are the factors we have? 1, 2, 3, 6. Add all of them. 12. So 6 also a perfect number. So among the natural numbers, 6 is the first perfect number. Next I found 28. You can find some more. Okay. Yeah, I am writing the definition. Perfect number. Write everyone and write the examples also. 28 to 6. So what is perfect number? Sum of, we can call divisors or factors, both are same. Sum of factors of a number. Sum of factors of a number is double to the number. So the type of numbers is called square numbers. Sorry, perfect numbers. So example 6, 28, some numbers also will be there. You find out them. Perfect number, composite number completed today. Still, what we discussed? Prime, composite, twin primes, co-primes. Okay, na? And I hope I told you how to find the number of factors of a number. Okay, if a number are in the form of prime numbers like 2 into 3 prime factors, their powers are taking and adding them. Okay, na? Did I tell you? I just send a message or not? Do we discussed about it? Next, absolute value. Next concept, absolute value or absolute number. Now, this symbol we are using for absolute value, modulus of A. For example, here A is any number, any integer. If you take like this, A can be any integer. There are two conditions you should remember. A value, modulus of A value is A, and the second situation is modulus of A value is minus A. Modulus of A value is minus A, where A can be any integer. Now the condition is here A greater than 0 and here A value less than 0. Okay, na? A value is greater than 0 for first condition. If you take any number in modulus, it will give always positive. Here also. Let us go through the examples. First example, modulus of 5. 5 is greater than 0 or not? Obviously. So answer is 5 only, because 5 is greater than 0. Now, second situation. I am taking minus 17. So what is the answer? Minus, here modulus of A means this one, entirely. A means entirely minus 17. So what is the condition? Minus 17 is less than 0. So here answer will be minus A. That means minus into minus become plus 17. Here minus 17 is less than 0. That's why we are taking minus A. So simply you can remember that in the modulus, if you take a positive value or negative values does not matter. It always gives in a positive way. That means the answer of any integer is always modulus is positive. Modulus of any integer always positive. But the conditions you should remember: modulus of A is equal to A where A value greater than 0. Modulus of A is equal to negative A when A value is less than 0. Okay, na? Where minus into minus become plus. That is called absolute value. Okay, na? Next we should discuss about the Pythagorean triplets. Pythagorean triplets. Triplet means three numbers are in the form of, for example, L, M, N. L, M, N can be any integer or any natural number. These are in the form of L square plus M square. First number square plus second number square equals to square of third number. Square of first number plus square of second number gives square of third number. Then these three numbers are called Pythagorean triplets. Pythagorean triplets. Okay, na? Let us see one example. Pythagorean triplets, where L, M, N are Pythagorean triplets if they are in the form of L square plus M square is equal to N square. Okay, na? Yeah. For example, 3, 4, 5. Let us check this. 3 square plus 4 square. It should come 5 square, right? 3 square value how much? 3 into 3, 9. Plus 4 square. 4 square value? 16. 4 square value 16. So 9 plus 16, 25. 25 is a 5 square or not? Yes. 5 5 is 25. So 3 square plus 4 square equals to 5 square. Then 3, 4, 5 are Pythagorean triplets. Pythagorean triplets. Okay. After giving that, I know already 3, 4, 5 are Pythagorean triplets. I can take the example. But you don't know whether it is a Pythagorean triplet or not. How can you find it? For that, the LMN are in one form. LMN are Pythagorean triplets when they are having in the form of L square plus M square is equal to N square, right? But these three numbers having one form, if the numbers are in the form of 2n n square minus 1 n square plus 1, the Pythagorean triplet, any triplet are in the form of 2n n square plus 1 n square minus 1. First one and second one can be interchanged sometimes. First one, second one, positions can be interchanged. Like 3, 4, 5, I am taking in ascending order, right? 3, 4, 5. Okay? Here also, smallest number we have to take first. That means in some situations 2n will be smaller than n square plus 1. In some situation n square plus 1 is smaller than 2n. That's why first and second positions can be changes, but the final position is same. Final position is same. Let us see. For this condition, one example. Here n is natural number, where n is a natural number. For example, I am taking if n value is 1. If n value is 1, what is 2n? 2n is equal to 2 times of n. n means 1. 2 ones are 2. Okay. Next, n square minus 1. N square minus 1 means n value 1 square, 1 only. 1 minus 1, 0. So, n is equal to 1 is not possible. So, here condition n greater than 1 and n belongs to set of natural numbers. Except 1. So, for remaining all it will be possible. Let us check. Let us check. N square minus 1, 2n, n square plus 1. First and second one positions can be changed, I said. Okay. Now, if n is equal to 2, let us find n square minus 1. N square minus 1. In the place of n, substitute 2 square. 2 square value 4. 4 minus 1 is 3. Okay. Now, 2n value. 2 into n value what? 2. 2 2 is 4. And third one, n square plus 1. N value 2, 2 square means 4. 4 square plus 4 plus 1, 5. So 3, 4, 5 Pythagorean triplets. If n is equals to 2. Okay, now? Let us find out for n is equals to 3. If n is equal to 3. So first n square minus 1. So 3 square minus 1, 8. Because 3 square value 9, 9 minus 1, 8. Next, 2n value. 2 into 3, 6. See, now this time 2n is smaller than n square minus 1. Next, n square plus 1. 3 square plus 1, 10. So simply 6, 8, 10 are Pythagorean triplets if n value is 3. Now you do for n value 4 and n value 5. Okay, children? So the triplet means the set of 3 numbers are in the form of L square plus M square is equal to N square, where L, M, N are called Pythagorean triplets. And the 3 numbers can be in the form of n square minus 1, 2n, n square plus 1, where n value is greater than 1 in the set of natural numbers. Okay, na? Now find it for n is equal to 4. Right now, just 1 minute time to you all. Okay na? Yeah, let us see n is equal to 4. Now find n square minus 1, 2n value, n square plus 1 u. Quickly. N value 4, 4 square 16, 16 minus 1, 15. 4 square means 4 4s are 16, right? Now 2n value, 2 4s 8. Now n square plus 1, so 4 square plus 1, 4 square value 16, 16 plus 1, 17. Therefore 8, 15, 17. Okay na? Now this time I am giving you one Pythagorean triplet, 5, 12, 13. These three are Pythagorean triplets or not, check. How to check? L square plus m square is equal to n square. Check that. Pi square plus 12 square. 5 square value 25. 12 square value 12 12 are 144. So 169. 169 is nothing but 13 square. 13 13s are 169. Third number also we know, no? 13 13 13s are 169. Yes, 5 12 13 are Pythagorean triplets. Okay na? So learn about the perfect number and co-primes, twin primes, absolute value, and this Pythagorean triplet are in the form also n square minus 1, 2n, and n square plus 1. Any other doubts? Yeah, one sec. Here onwards. Okay, children. So once revise this concept, take n value 5, 6, 7 like that. Find out the Pythagorean triplets. It is work out or not? Once check it out. And next class we will discuss about that perfect number and all again deeply. And number of divisors formula I gave you already. And let us find out for sum of divisors. Okay, na? So we will see in the next class. Thank you one and all. Next maths class, okay?